In this problem, you are asked to identify the domain and the range of the piecewise function that's given to you. So there's really no surprise. You're going to use the old drill we had. Whenever you're trying to talk the domain, you look at your function, whether it has a denominator, whether it has a square root. You need to rule out those possibilities. And whenever you have a discussion of the range, you want to look for the graph so you can see the height it swiped through. So look at my function. I realized it has two pieces, both of which were something that's defined from negative infinity to positive infinity. Even I put some constraint on top of that. Therefore, when I try to talk about the domain of my linear and quadratic function, it's pretty intuitive for me to realize right away there are no points that I need to worry about. So they should be defined everywhere. In other words, negative infinity through positive infinity. The next thing I'm trying to discuss here is what the graph is like. Okay, in order to discuss a graph, the first thing is you make a cut at the point of -4. So you know you'll be sketching two things on the left and right side of it. On the left of it, when you are less than -4, you realize when -4 plus 4 is 0, so you're going to go through this point. And then when you have -5, your function has a height of 1. Let me put it a little bit lower. So here, so the graph of the left side is something that goes like this. And the graph on the, I'm sorry, my bad. If I had input to be -5, my function value actually is supposed to be -1, not +1, right? -5 plus 1 is -1. So my graph goes like this. The other thing I want to plot is a graph of x squared plus 9. X squared plus 9, if you look at it very carefully, it's actually a quadratic function in the standard form where the vertex is 0, 9. So you realize your graph should have a vertex at this point. Because the coefficient in front of is +1, so your graph should be facing up. So I didn't really need all the details. I do know my function has a smallest function value, and it can swipe through all the way till infinity. So for this part of the graph, you will realize that it would cover up the height 9 through infinity. For this part of the graph, you are going to cover the height of -infinity up to the height of 0, and because this is a circle, so you can't really capture the height of 0. You can only get extremely close to it. So the range of your function is technically -infinity through 0 combined with 9 through +infinity. So that's supposed to be the answer of my problem.